Welcome to Ask and Learn.
So we have a person here who is swinging, and there's a rope hanging here, and he runs with a velocity of 5 meters per second, catches hold of the rope, and we have water here. And then finally he swings to this location and makes an angle of theta, and his velocity at this point becomes 0. And the rope length is 10 meters. So we need to find out the angle theta when he releases the rope. So we can assume that at this point y is equals to 0, and v1 is 5 meters per second, and v2 is equals to 0, and we just need to find out the height, this height, which is y2. So we apply the law of conservation of energy at these two locations 1 and locations 2. So we'll write E1 equals E2 half mv1 squared plus mgy1 should be equals to half mv2 squared plus mgy2. So we equate this equation half mv1 squared, because this is 0, so therefore it is half mv1 squared on the left, equals mgy2, because the velocity becomes 0 at this location. So therefore we get y2 is equals to v1 squared over 2g. This is basically equals to this h, this vertical height. So now in this location here, if we find the cosine of this angle, so cosine of this angle should be equals to, now if this is h, then this distance is L minus h. So in this right angle triangle, cosine of theta is this divided by the hypotenuse. So therefore cosine of theta is L minus h divided by L, which is actually equals to 1 minus h by L, which is equals to 1 minus v1 squared by 2gl. So because in this equation we have h is equals to, if you can see here in this equation here, so h by L. So h by L, which is this, is equals to v1 squared by 2g. So if we equate this equations, we have cos theta. So theta is equals to cos inverse 1 minus v1 squared by 2gl. So if you plug in this equation, we'll get 29 degrees as the value of theta. The B part is that they're asking what is the tension of the rope just before he releases it. So for the B part of the equation here, so this angle is theta, and the tension is Ft, and we have the force acting as mg. So we have this angle is theta. So we can find out the net force along the radius, which is equals to the tension minus mg cos theta. So at this point, the net force, which is equals to 0. So therefore the tension force is equals to mg cosine theta. Which is equals to 56 times 9.8 times cos 29, and that should give you 480 newtons. Now at this point the velocity is 0, So Ft minus mg cos theta is 0, and it is actually equals to mv squared by r, the centripetal force. But since there is no velocity at this point, the centripetal force must be equals to 0, hence net force is 0. Therefore, I put it equal to 0. So therefore, the tension is equal to mg cos theta, and we can calculate tension as 480 newtons. All right. What is the maximum tension in the rope? So we write the Newton's law as net force is equals to Ft minus mg cos theta is equals to mv squared by r. So therefore, Ft is equals to mv squared by r plus mg cos theta. Now, as this angle decreases, the tension increases, and as the speed increases, the tension increases. Now, both effects are the greatest at the bottom of the swing. So there is where the tension will be at its maximum. So therefore, we have Ft max is equals to mg cos 0 at the bottom of the spring plus mv squared by r, where the tension is going to be the maximum. So we'll just simply get 56 times 5 squared divided by 10, and that should be equals to 690 newtons as the maximum tension at the lowest point of the rope.